Okay. All right, so any questions about what we talked about yesterday? Does everyone understand what we did, or do we need to sort of review? Well, we are going to review a little bit, but was there any glaring questions that you have that I need to answer in the beginning? All right. Okay, so yesterday we talked about quite a few things, okay? Let's just go back. We talked about two forms of a quadratic equation. The first form is known as the standard form. And it is when the quadratic equation is in the form ax squared plus bx plus c. Then we talked about the vertex form. And that's when the equation is in the form a times x minus h squared plus k. Okay. And we said the vertex is hk. Okay. And the formula is for the x coordinate negative b over 2a. Okay, where b is the linear coefficient, a is the leading coefficient, and to find k, plug x back in. Okay, then we said that if we want to know the axis of symmetry, that's the axis along which you can fold the parabola in half and one half of it will land on the other. It's given by the equation x equals the x coordinate of the vertex, right? Then we said that the leading coefficient tells me which way the parabola opens, okay, up or down. If the leading coefficient is positive, it opens up. And if the leading coefficient is negative, it opens down. Okay. Then we said that if we want to find the y-intercept, where the graph crosses the y-axis, that is given by 0, comma, the constant term c. And the x-intercept is basically we solve the equation by factoring. Now, yesterday we talked about a problem type, something like this. Okay. And we said if we want to solve this equation for x, when we have an equation in vertex form, we have to get this part, this square part by itself. So we move 32 to the opposite side. Then we divide by 2, get rid of any leading coefficient. Then take the square root. This is where this is important. This is the square root property, where you take the square root of both sides. Okay. And then taking the square root of a square, they cancel each other because they're inverse operations. And the square root of 16 is positive and negative 4. You have to include both the positive and negative version. 4 squared is also negative 4 squared is 16. And then you solve by adding 3 to both sides. So my answers, I have two answers, 3 plus 4, which is 7, and 3 minus 4, which is -1. Okay. And these are my x-intercepts, which is off the x-axis. So you use the square root property when the equation is in vertex form. If it's in standard form or, in standard form, then you have to factor. Okay. Or at least that's the only way we know how to solve a standard form equation for x. Any questions about any of these? Are we good with all of these?
Yes.
Okay. All right. Now, let's talk about going from standard to vertex. Okay. So to go from vertex to standard, all you have to do is square the binomial, multiply through with your leading coefficient, and combine like terms. So let's do one of those first. Okay, so let's say I have an equation in vertex form, and I want to do it in standard form. Well, I'm going to square the binomial. So when you square a binomial, if you remember from our discussions in class, there's two ways you can go about it. You can either multiply the binomial by itself using foiling, or you can use a formula that a plus b squared is the first term squared plus the second term squared plus or minus, depending on what the middle sign is, 2 times the first term times the second term. So in this case, x minus 3 squared would be x squared plus -3 squared plus 2 times x times -3. X squared is x squared. -3 squared is 9. Remember, when you square a negative, it becomes a positive. And 2 times x times -3 is -6x. And if we wrote this in descending order of power, there we go. Right. So this is how my equation looks so far. So now, in order to finish completing this, finish it in vertex form, we're going to distribute the 2 first. Remember, you multiply before you add, so you distribute the 2. So 2 times x squared is 2x squared. 2 times -6 is -12x. 2 times 9 is 8. Then the last thing we do is combine my constant terms. There we go. All right. So going from vertex to standard is easy. You just have to square the binomial. Okay. Now, going from standard to vertex is difficult, okay? It's not as straightforward. Okay. Now, let's take, for example, then there's 2 ways to do it. And the way I would prefer you to do it is called completing the square. Okay, so let's do an example. Let's do x squared minus 4x. Okay. And it's in standard form, and I want to make it into vertex form. So step 1, move the constant term to the opposite side. Okay. So how do I move? I subtract 1 sides, and I get y minus 1 equals x squared minus 4x. Okay. Now, step 2, factor out the leading coefficient. Okay. Well, in this case, the leading coefficient is 1, so there's nothing really to factor out. But sometimes you may have a leading coefficient that's like 2 or 6 or something, and you have to factor the 2 out from both of these terms. Okay, and we're going to do an example where that is. Okay. In this case, the leading coefficient is 1. We don't have to factor it out. Now, step 3, we take the linear coefficient, which is, okay, well, in this case is -4. What we do is divide it by 2 and then square it. So -4 divided by 2 squared. Okay. So -4 divided by 2 is -2. Squared gives me 4. Now, we take this term and add it to both sides of the equation. Okay. So y minus 1 plus 4 equals x squared minus 4x plus 4. Okay. Now, left side of the equation, combine like terms. And right side, I want you to factor. Okay. So left side of the equation, it becomes y minus 1 plus 4, which is plus 3. Okay. And on the right side of the equation, x squared minus 4x plus 4, when you factor this, remember this is a perfect square trinomial. And I know it's a perfect square because it is in the form a squared plus 2ab plus b squared. So the first term is a perfect square. The last term is a perfect square. The middle term is 2 times the first term times the last term, okay? And when you factor a perfect square trinomial, this is what you get. The square root of the first plus or minus, the sign is in the middle, the square root of the last. So the square root of the first term is x minus, because the middle sign, this sign right here is minus, the square root of the last, which is 2. And the last step now is to move the constant term from the left to the right. So remember, when we move, we subtract 3 from both sides. And my final answer is y equals x minus 2 squared. So just to recap, The first thing we did was move the constant term to the opposite side. Okay, so we subtracted 1 from both sides. Then if we had a leading coefficient other than 1, factor that out. Then we took the linear coefficient, which is b, -4, and divided it by 2. And squared it. Okay. So b -4 divided by 2 is -2, and -2 squared is 4. Then we took this result and added it to both sides of the equation. Step 4. Okay. Step 5, left side, we combined like terms. So -1 plus 4 is +3. And we factor the right side. So when we factor this, this is square root of the first term, plus or minus, depending on what this sign is, square root of the last term. And all of it is going to be squared. Then the last step was move the constant term from the left to the right by subtracting. And that is known as completing the square. Okay. Now, let's look at an example where the leading coefficient is something other than 1. So let's take, for example, y equals 2x squared minus, let's do 12x plus 3. All right. So step 1, we move 3 to the opposite side. Okay. Now, step 2, this is what's important. The left side stays the way it is. The right side, we have to factor out a 2, the leading coefficient, which in this case is 2. When you factor out a 2, 2x squared divided by 2 is just x squared. -12x divided by 2 is -6x. Okay. Now, step 3, we take b, which in this case b is -6, divided by 2, and then square it. Okay. Now, we take this result and add it now to the inside of this equation. So, and remember, when we add it to the right, we're going to have to add something to the left. And I'm going to come back in a second and explain what we have to add to the left. Now, I added 9 to the inside, to the right side of the equation. But on the left side, I can't just add 9, okay? Because I'm not really adding 9 to the right side, okay? I'm actually adding 2 times 9. I'm actually adding 18. So if you look at what I'm doing to the right side of the equation, the right side of the equation is actually 2x squared minus 12x plus 18. Okay, does everyone see that? If I factor out, if I distribute the 2, this is what my expression becomes. So I'm not just adding 9 to the right side, I'm actually adding 18 to the right side. It's whatever I found this to be times my leading coefficient when I just factored out. So 9 times 2 is 18. So since I'm adding 18 to the right side, I have to add 18 to the left side. Okay. And that's important because that's where a lot of students make a mistake, okay? We didn't have to worry about that in the previous problem, but in this problem, we have to pay attention to what we're actually adding. We're not, again, to repeat, we're not just adding 9. We're adding 2 times 9, because if we distribute back this 2 that we had factored out, that would give me 18. So it's 2 times 9, which is 18. So if I'm adding 18 to the right side, I have to add the same amount, 18 to the left side. Then everything else pretty much stays the same, okay? So the first thing we do is combine my like terms on the left side, which gives me 15. And on the right side, I factor. So it is the square root of the first term, which is x, plus or minus, depending on what this is. So minus the square root of the last term. And we finish up by subtracting 15 or moving 15 to the opposite side. There we go. It's a lot of steps, and you need to practice the skill because it is going to be important that later on. Okay. Now, let's say, for example, you didn't want to complete the square. There will be problem types that you will have to complete the square on. If you also just wanted to do go from standard form to vertex form, you're more than welcome to find h and then find k and then plug it into that formula. Okay. So let's take, for example, the same equation. So in order to convert this to vertex form, remember vertex form is a times x minus h squared plus k. And from standard form, we get a is 2, the leading coefficient is 2, the linear coefficient is -12, and the constant term is 3. So remember, how do we calculate h? It's negative b over 2a. So negative of -12 over 2 times a. That gives me 12 over 4, which is 3. Right? And to find k, we have to plug the 3 back into the equation. And solve. So first we do the exponent. Multiply. So 18 minus 36 is -18, plus 3 is -15. Now that I know what my h and k is, h is 3, k is -15, and my leading coefficient is 2, I'll plug it in. Y equals a, which is 2 times x minus squared plus k, which is -15. So that's another way you can convert from standard to vertex form. Okay. Any questions on that? I know I went through it pretty fast, but I'm going to do a couple of examples more. But does anyone have any questions? Well, anyone? Does everyone get it? Or was it a lot of information at one shot? Ms. Deputy, do you get it? Mr. Miguel, do you get it?
Over stuff.
All right, so let's do an example. All right. Let's start off easy. I'm going to give you an easy one, and then we'll ramp up from there. Okay. Given an equation in standard form, convert this into vertex form, please.
Wait, that's in the standard form?
Yes, it's in standard form. Remember, it's ax squared plus bx plus c.
Yes, sir.
So now I want you to convert it into vertex form. All right, so let's get started. So the first thing, remember, we have to move the constant term, which is 45, to the opposite side. So remember, how do we move a number across an equal sign? We have to do the opposite operation. So it's plus 45, so we subtract 45 from both sides. Okay. Now, we factor out the leading coefficient, but the leading coefficient here is 1, so there's really nothing to factor out. So because of that, we can go ahead and move on to the next step, which is identify my linear coefficient, which in this case is 14. Then we take the linear coefficient, divide it by 2, and square it. So that's 14 divided by 2 squared, which is 14 divided by 2 is 7. And 7 squared is 49. Okay. Now we take this result and we're going to add it to both sides of the equation. All right. Then we're going to combine like terms on the left side. That gives me negative 45 plus 49 is 4. And on the right side, we're going to factor this. So it's the first term squared, first term, square root of first term, plus or minus, which in this case is plus, the square root of the second of the last term, which is 7. Okay. And then we're going to move the constant term back from the left to the right by doing the opposite operation. Okay. So this is pretty straightforward. When the leading coefficient is 1, you don't have to worry about what you have to add to the left because it's the same number. Okay. And when you complete the square, this is probably the easiest completing the square problem type you'll get. Now, let's do another harder one. Okay. So negative 3x squared plus 24x minus 11. So standard form converted into vertex form, please. So let's get started. So the first thing, we're going to move the constant term to the opposite side. Now, in this case, the leading coefficient is something other than 1, so we have to factor out the leading coefficient on the left. So the leading coefficient is -3, so we factor it out. So -3x squared divided by -3 just leaves me x squared. And 24x divided by -3 is -8x. Okay. Now, we identify the linear coefficient, which in this case is -8. Then we're going to take that linear coefficient divided by 2 and square it, which gives me -4 squared, which is +16. Again, remember when you square a negative, it becomes positive. Now, we're going to add the 16 to the inside of the parentheses on the right. Now, to determine what to add on the left, it'd be 16, what we added on the inside of this parentheses, times -3. So 16 times -3 is -48, and we're going to add that to the left side. Now remember why we're adding -48 and not 16 is because if we distributed the -3 through, we would get -48 on this side. So we actually didn't add a 16, we added a -48. So if we add -48 to this side of the equation, we have to add the same amount to this side. Now we clean it up, we combine like terms on the left. So +11 minus 48 is minus or -37. Okay. And on the right, we factor what's in the parentheses. So it is the square root of the first, which is x, plus or minus, but in this case it's minus, the square root of the last term. So the square root of 16 is 4 squared. Now we finally finish up by adding the constant term back to the right side of the equation. And that's my final answer. Any questions?
No.
Okay, so I know it's a lot of steps, but you need to know how to do it because later on, this is a way we're gonna use completing the square to solve equations. So you need to know or be familiar with how to do these steps. Now you're more than welcome to do it the other way, where you find h by using -b/2a and then plugging that h back in. You're more than welcome to do that, but I think this way is better. Okay. So this is where we're going to stop for today if there's no questions, and I will upload this video later on today. I have been having internet problems, so it will be a minute or so before it gets up on the websites. And if you have any questions later on today or over the weekend, please reach out to me. And if you have any technical issues with Edgenuity, also reach out, okay? Make sure that you get done with the nonlinear functions unit, because I think that this week the test was due, so make sure the test is done. And yeah, if you have any more questions or concerns, just let me know. All right? All right. Y'all have a nice day and have a great weekend, and I will see you guys Monday. Okay.
See you, Mr. D.
All right.
Have a nice day.
Have a nice weekend.